Okay, good afternoon, everybody. Good morning, good evening, wherever you're listening from. Welcome to our next steering committee election session. I'm joined today by Professor Ge, National University Singapore Deputy Director. But Professor Ge, perhaps you could start by giving us an introduction, a bit of background, and a little about yourself to let the community get to know you.
Hello, hi everyone. My name is QD. I'm currently the Deputy Director of Industrial Development at Center for Advanced 2D Materials, National University of Singapore, which we are the ranking #1 university in Asia. I bring a unique combination of expertise in materials chemistry and nanotechnologies, along with extensive experience in commercial product development and business growth. My passion focused in addressing energy and environmental challenges using advanced materials. And I have been working on the fundamental studies of 2D materials for over about 10 years now. My past work includes exploring the use of 2D materials in batteries, fuel cells, biosensors, and pollution control. I have been successfully in creating flexible electronics using graphene-based structures. I do hope that my background can bring VeChain to the next level or have some support to help VeChain to build up. Thank you.
Love it. And I mean, this is an area I'm particularly fascinated in. Like graphene as a material, of course, has so much promise for the future of electronics and all kinds of applications. So really great to have you here, and an expert in a really innovative field. So perhaps you could explain a little more why you're interested in joining VeChain.
Well, it's good to know that you are interested into graphene, which is part of my job that I have been focused for my last 10 years research. Well, over the years, I have been working on novel functional materials. Materials which can be programmed to perform specific tasks. One big application for such system would be the local production of energy from ambient environment. Energy is generated from the local temperature gradient, illumination, vibrations, etc.
Oh, wow.
It is clear that such structures will contribute importantly to the overall balance of energy produced and utilized. Well, they will be an important contributor to our overall sustainability efforts. At the same time, there is another big problem I think we're facing. Even if we are producing enough energy locally, can we really efficiently store and distribute it? This problem, I think, is as important and complex as the energy production itself.
Amazing.
It is very clear that we will have very diversified markets of energy in the future. But how to compare different energy production methods in terms of their efficiency, environmental friendliness, ability to be stored and accumulated. Smart contracts are the only way forward. But we need the new generation of smart contracts, those which can be settled efficiently with minimal energy use. So where I focus, the functional intelligent materials can partake this function. They can contribute to energy production, distribution, and verification. I'm really interested in those aspects of smart contracts. And I think there will be a lot of interaction between the material science, computer science, AI, theory of complexity, and the rest. Hence, I'm really like to join VeChain for the future.
Amazing. Yeah, that's fascinating. I agree with your vision. 2D materials will change everything, and obviously blockchain, AI, the combination of very, very potent technologies. Great. Okay. So, you've obviously got a rich background. What relevant experience or expertise, can you bring to the VeChain Foundation on top of what you just discussed?
Oh, that's a very good question. What relevant experience I can bring to VeChain Foundation? I have been working on sustainability, green energy, carbon utilization for a number of years now. All those topics will be extremely important for our future development. At the same time, I realized that an overreaching platform linking all those topics I mentioned needs to be created and implemented. But I also want to see this platform to be distributed across the users. Being highly accessible, we need to distribute the production and the utilization of energy. Functional intelligent materials we have been working on over the last few years, which I believe can definitely contribute to this agenda, could make every one of us an active player in the global effects of green economy. I can see that in the future, our energy production will be much more diversified and distributed. Let's think already now, we can generate our own electricity and biogas and sell it back into the grid. It's already happening. We will use power generated from temperature gradient of our body, from vibration of our clothes. This will allow us to reduce the environmental impact, but also will require design of new materials and smart systems. Integration of such systems into the global energy network will be a challenging task, which I think will require efforts of people with very different expertise, from material science to computer science. If I am elected to become the member of the steering committee, I will bring my colleague, Professor Sir Constantine and Professor Sir Andrew, to join VeChain as well. Those two Nobel Prize winners will definitely contribute their scientific knowledge and large perspective, which I believe it will increase the value of VeChain and VET significantly. I will also ask not only my working colleague, Professor Jonathan Cooper, but also a very close friend. He is a fellow of the Royal Academy of Engineering in the UK and the vice president of the University of Glasgow, based in Scotland, to join VeChain. Can you all imagine all those well-known scientists joining VeChain? How much impact can they bring over? Thank you, Jack.
Amazing stuff. And I love a topic you touched on there with the generating electricity from just movement or temperature gradients. My dad's actually worked with something called piezoelectrics, which I noticed you have as well. And obviously generating current from bending materials. This is revolutionary if it can be put to scale. Fantastic answer. Thank you, Professor Gur. You've got a grand vision. How do you envision VeChain in 5 years from now?
Ooh. How do I envision VeChain in 5 years from now? That's a very good one. Okay. VeChain needs to create a low-cost, efficient platform for energy production, distribution, and utilization, which could be accessible on the grassroots level. I think it needs to be able to deal with very different energy production methods, ways of storage and distribution. This is a very ambitious goal, which I think probably longer than 5 years. But we need to be able to see the basic skeleton for such a platform in the coming years. Ideally, such platform should incorporate and work with very different energy producers. Transporters and users can be completely decentralized. Decentralization, transport nature of such system could open the energy market and bring the choice of the energy to be responsible consumer. This would require very good understanding of energy life cycle, as well as environmental and sociological impact. Developing the metrics which would allow easy calculation of the energy production, conversion, and transportation cost. This would be a realistic target for the next 5 years. Making such a system is highly autonomous and optimized will pave the way for the global goal of forming truly decentralized platform for energy. Thank you, Jack.
Amazing. Okay, well, bringing it back to the foundation, what, in your opinion, is the biggest challenge you think the foundation faces, and how would you solve it?
The biggest challenge of the foundation faces. Well, that's a good one. I think if we are serious about creation of a sustainable future, everyone needs to be involved. It is about personal participation and responsibility. Blockchain system is designed to be capable of accounting for it, but it has never been tested on such a scale. Making it efficient but inclusive at the same time is one of the biggest challenges I think VeChain faces in the next few years, the foundation. We will be using very different sources of energy with different impact on environment, different productivity, and different usability. A smart way to compare those and to account for different sources will be needed. Let's say life cycle analysis of energy produced by different means would be essential for such system, which would allow consumer to make a smart choice when selecting the particular energy source. Ideally, it could be made at the background automatically, accounting for many different factors altogether. Smart materials will be an important player of such a system, capable not only of the generation of energy, but also providing information about its source and efficiency. Designing such a system is a massive engineering and social task, which will require a number of new and out-of-the-box solutions, which I think. Thank you, Jack.
Great answer. Thank you, Professor Gur. Okay, assuming you were elected as a steering committee member, how much time and effort do you think you could dedicate each month?
Oh, okay. May I ask you, Jack, how much time do I spend on my research?
Well, I imagine quite a lot.
Yes, all the time. All the time. I never stop thinking about my work as a scientist. Well, luckily, my scientific interests overlap strongly with the goals set by VeChain. Well, so I expect a very close cooperation. This would include many aspects. Let's say on the fundamental level, we will be researching into functional intelligent materials, which will be capable of smart energy production and conversion. Integration of such local production of different types of energy into the grid, and its automated accountability is a very important task as well, which hopefully will be done with the additional functionalities of our smart materials. On a more applied level, we will be creating matrix for the life cycle of the production, conversion, and transportation of energy. I think a number of experiments will need to be done, especially in relation for hydrogen and carbon-based economics. I would say it is a global task, and we expect to collaborate with several other centers across the globe. Thank you, Joe.
Very fascinating stuff. I mean, I've got a bit of a background in environmental science, and energy is such a fascinating topic to me, and sounds like amazing work you're developing.
Thank you.
Great stuff. So moving on, as you may be aware, well, as you are aware, sustainability is a big focus for the VeChain Foundation. What do you think about sustainability as the strategy of VeChain? Do you believe in it, and why do you believe in it?
Oh, the sustainability as the new strategy of VeChain. I think it is not a matter of belief, Jack. Sustainability is the necessity and our responsibility as human beings. So it is not a matter of belief. We simply must do it. These might be different approaches, but overall, we must change ourselves, our behavior, our technologies to become sustainable. I do think that smart contracts for energy and carbon credits will help to bring the idea of sustainability closer to reality. And that's the reason, and that's also the reason why I support VeChain to approach. For many, many years, we ignored sustainability, focusing on economic growth without considering ecological and social impact. In the future, we will need to change the criteria for success. Of course, adding the sustainability as an important factor on top of economical viability. It is a challenging paradigm change. But of course, it must be done. First of all, in our heads, it doesn't matter how successful you are in economic indicators if you are borrow the future from your children, from your kids. I'm sure that VeChain platform will help here, but we will also need to convince people to use it. It should be the behavioral change. Our attitude to consumption of the resources also needs to be changed. The platform will be an important factor here, but it cannot be done or just cannot be changed alone. Of course, I think education will be an important contributor as well to catalyze the shifts in human behaviors as well. It might take another generation before our attitude will be changed. But I do believe sustainability is the future and something we have to take it more serious than before. Thank you.
Great answer. Yeah, I mean, I totally agree. And that's why I think the kind of tokenization model, incentivized participation model that VeChain is pursuing is so compelling because, it encourages that shift, which is a powerful psychological hook, right? Great stuff. Thanks for your answer. So
Thank you.
In terms of then the Web3 arena, what do you think about the opportunities for VeChain in Web3?
The opportunity of VeChain in Web3. I think this is the only realistic approach if we want proper accountability of energy, of our energy production and usage. In the future, we will see even larger diversification of energy production methods. Can you imagine that? With local production becoming increasingly important, decentralized accounting system would be required to make it efficient. One of the biggest reasons why sustainable technologies are not processing fast enough into our life is that it is very difficult to compose a lifetime analysis of a particular energy technology. Depending on the method of production, transportation, or utilization, the impacts on environment might be very different. Generally, it is difficult to account for all those factors within the system we use today, which leads to the fact that very strong subsidies go to the wrong directions and really breakthrough technologies cannot find its way to the market. Decentralized, self-adjusting system, if properly tuned, might becoming a solution for this problem. But however, a lot of data needs to be plugged in, and a lot of trust obviously need to be assigned to it. I think this will be a step learning curve for figuring out the actual number and understanding the complex relations between different parts of the global energy network. I'm sure that artificial intelligence will be used a lot for this. Everybody heard of the new AI. I'm sure that some of you have been used. So the Web 3.0 might be the good platform to provide data for this. That's my opinion. Thank you, Joe.
Yeah, no, totally agree. I think we touched on it recently, how powerful ChatGPT is just on the basis of what exists now on the internet. And I think it has a cutoff of like 2021, right? So it's still limited in its knowledge. But when you bring blockchain and oversight of so many data points at any one time, I mean, that's going to be insane, like real-time information at a massive scale. I mean, it's groundbreaking. Thank you. Cool. Right, moving on. So what makes you believe you can contribute to VeChain's strategy? What are your unique strengths that will help VeChain achieve its goals of mass scale adoption?
A very good question. Okay. What makes me believe I can contribute to VeChain's strategy? Okay. Over the years, we created multiple solutions for energy production, storage, and management using smart materials. With the energy production being diversified and decentralized, a lot of pressure on the new solutions for such application and new functional materials will be playing the key role here. Importantly, the materials need to be smart to actively participate in the process of energy distribution and the contracting. Such solutions are only being developed now, but I think will play the key role. Furthermore, in order to synthesize some of our carbon-based materials, we extract the greenhouse gases from what? From atmosphere. from atmosphere, contributing to carbon management. New technologies of methane conversion into hydrogen and carbon, avoiding the oxidation state, are being actively developed. There will be a need for more of carbon-based technologies, which are also being developed right now. Thus, the hydrogen technology is closely linked to carbon technology, and both provide one of the possible platforms for sustainability. Combining our solutions with the VeChain platform will allow much wider spread of the green and sustainable technologies across the globe. Smart contracting for energy, hydrogen, carbon credits needs to be interlinked in a transparent, through probably a very complex way. This is where the expertise of VeChain proved here, I think. Thank you.
Great stuff. Yeah, again, touching on some fascinating topics. Like carbon capture is obviously quite a vital thing, and I assume that's where 2D materials come in, right? Graphene is a medium for that. Yeah, very, very cool stuff. Okay, let's move on. So we've touched on Web3, we've touched on sustainability, but how do you believe Web3 can be applied in the field of sustainability? So this concept, how is it being applied in sustainability?
How do I believe Web3 applied in the sustainability? I think that decentralized energy production, management, and utilization through a system of smart contracts will allow much faster spreads of green, sustainable technologies. Realistically, only self-regulating smart system can deal with the complexity we are facing. The energy market will be strongly diversified and decentralized. Also, if we want real innovation to happen on the energy market, we need to ensure the openness, free movement of investment, cross-border trade, competitions between different technologies. But all those need to be done within the restrictions of sustainability. The market needs to be not the price-driven, but sustainability-driven. Basically, VeChain creates a sustainability currency. But sustainability is a global phenomenon. It is impossible to be sustainable in the USA or in Singapore or in Japan, and that's not sustainable everywhere else. How is that possible? And such global challenge can only be solved using a cross-border tools. Web 3.0 is exactly the method which needs to be applied here. I'm sure it will be evolving over the next few decades. Probably new sub-tools will appear, which are specific for the sustainability and energy sector. But Web 3.0 is a very good starting point, for sure. We would also aim to develop a set of a comprehensive carbon tracking network in combination with blockchain protocols to account for carbon decreased, absorbed, reused, energy produced, and saved as a result of our technologies, industrial and commercial uses. As a result, carbon credits will be issued which may be used as a value reserve for native cryptocurrency on the chain. And the token will behave similarly to a stablecoin, or at least have some of its properties in the near term. Communities can use the coin for any typical commercial activities supported by the chain's ecosystem. But they will also have the option of using it for carbon trading. Security, transparency, and auditability are apparent benefits of having this accounting system and the trade mechanism on chain. This is my opinion, Jack. Thank you.
Love it. Great stuff. And touching on some exciting things, really, new tokenomic models and, in terms of Web3 applicability and sustainability, I love the idea that it transcends governments, enterprises, people that may have an agenda. There's no hiding the truth with blockchain and Web3. It forcibly levels the playing field, which is what makes it so powerful.
Yes, they are.
Great stuff. Great stuff.
Thank you.
Thank you. I appreciate your solid answers. So let's move forward again. So looking now more to the crypto market, what do you see as the next hot topic, and how should VeChain adapt to it?
Oh, the next hot topic. Oh,
big one.
That's a very, very big one. And okay, let me have a think. I think we will need to find other commodities which can be helped to manage with the use of blockchain. Energy is very important, but other resources, such as water, for instance, can be managed through the same technology. I think it will help enormously with the efficient and sustainable management of such resources. Effectively, any resources which are global in accumulation, global in trade, and global in utilization can and should be managed on crypto market. As I have mentioned, water is one of such resources. Maybe global debt is another one. Computing resources, especially those connected to AI, might be another one. We are also trying to work on the scientific knowledge registered with crypto technologies on distribute platform. Let's say Web 3.0, for instance. Scientific knowledge is a true global phenomenon. It is created globally and utilized by every single one of us. However, the problem of distribution and verification is still very daunting. I think crypto-based technologies for ensuring the transparency and verifiability of scientific knowledge would be a very interesting platform. This could be the hot topic in the crypto market and how VeChain should play. What do you think, Jeff?
Yeah, no, I love it. And again, fascinating topic. You can expand blockchain to so many kind of environmental areas. I heard of a really fascinating use case where you can basically use IoT and cheap Internet of Things technologies to monitor forests, and you can tell if a tree is being deforested and get insights in real time. Some illegal activities going on, then you can alert the authorities. And resource management at large, I guess, is such a massive potential application for blockchain, and the scale of adoption is so huge in that sector alone. I mean, it's mind-boggling, really. Amazing stuff. Okay.
Okay, thank you.
Thank you. Okay, so a question here then. VeChain has been around since 2017, right? So it's considered a dino project. We've asked a few of our speakers this question. What are you bringing to make sure VeChain stays fresh and gets ahead of the market in the coming years?
Oh, Jack, what is that exactly mean, a dinosaur project? Sorry.
They're just old, It's been around for a while, so it's more of like slang. It's a bit of a slang term, but it's like, oh, VeChain's just an old project, and it's almost kind of dismissing it. But how do we stay relevant and strong in the future?
Thank you. That's how I learned what means a dinosaur project. Okay. I think it is not the time when technology has been created or when VeChain has been, established. It is if it provides the best tools to solve the particular problem. Being green and energy efficient from the start, VeChain is a perfect vehicle for the sustainability project. So what's the matter to call it a dinosaur project? It is not about the time. Sustainability is a very complex matter, which requires a lot of expertise, a lot of experience, very steep learning curve, novel solutions. It will require a team consisting of many different talents. From computer scientists to business analytics and physics and climate expertise. It is a company which will manage to combine the strongest team and move with the highest speed will lead the market. Assembling such a team and manage it to gain the maximum efficiency from the distributed sustainability platform will of course require a lot of experience, which indeed I can see it from VeChain. I would definitely be happy to be part of VeChain and to bring the talented researchers in energy, sustainability, carbon to work with us together. It will be a long process to form the optimized platform to manage carbon credits and sustainability in general. But with the right talents people, it definitely can be done. That's my view.
Great stuff. I mean, I think the crypto market, it moves fast. There's lots of trends, there's lots of narratives, but perhaps sometimes people don't understand how the real world works, which is, laying foundations, regulations. VeChain's obviously been involved quite closely in Europe with setting standards and frameworks, and it's really, I guess on the surface, kind of boring, but it's so vital, and that's the only way to mass adoption. This is what a lot of people in the crypto realm miss, but I think that will make VeChain one of the only viable platforms as we move forward into this regulatory era to actually do this stuff. Because it's there with with the DMVs of the world and building those frameworks. Not the coolest, but the most important. No, great answer.
Agree.
Yeah, great answer. And obviously talent, amazing talent across the board from the team, and individuals like yourself is so important. So we've touched on your 2D materials background. Again, another fascinating field. Personally, a huge fan of graphene. I've written some articles about it back in the day. How are you going to apply nanotechnology in the blockchain and Web3 space?
Okay. This is a very good question. I quite like this one. It's more focused on my research. Nanotechnology has the potential to revolutionize the blockchain and Web 3.0 industries by enabling faster and more efficient data processing and storage. For example, let's say nanotechnology can be used to create nanoscale transistors that are faster and more energy efficient, enabling the creation of supercomputers that can process large amounts of data, of course, more quickly and efficiently. Additionally, nanotechnology can be used to create nanoscale memory devices that are much smaller and more dense than current memory devices, making it possible to store vast amounts of data in a compacted space. This will be particularly useful for the blockchain industry, of course, where large amounts of data must be stored securely and efficiently. Nanotechnology could also be used to create nanoscale sensors that can be integrated into smart contracts and decentralized applications to enable new types of interactions and transactions in the Web 3.0 era. What do you think, Jeff?
Yeah, I mean, you're making my imagination run wild. You talk about nanosensors and materials that can generate energy from heat differentiation. So maybe, at some point you get Internet of Things devices that are powered themselves. They're always connected, but always powered. I mean, that's mind-boggling. I guess that kind of moves nicely into the next question I've just thought up. How nanomaterials could be used to make IoT sensors that support blockchain?
The Internet of Things is a very hot topic.
Yeah.
Okay. The Internet of Things IoT you mentioned definitely has the potential to revolutionize the way we interact with the world around us. And nanotechnology can play a key role in enabling this by creating highly sensitive and energy efficient sensors. Nanotechnology on nanomaterials. Let's focus on nanomaterials, such as graphene, which we mentioned very early on, or carbon nanotubes. They all can be used to create nanoscale sensors that are highly responsive and able to detect changes in their environment with remarkable accuracy. Nanoscale sensors could be integrated into blockchain-based IoT devices to enable secure, decentralized data connection and transmission. Those sensors could be used to monitor the environment, also to collect the data and trigger smart contracts on the blockchain.
Wow.
Let's think about some example. For example, a nanoscale temperature sensor in a smart refrigerator could detect when food is spoiling and automatically trigger a smart contract to order fresh groceries. Nanoscale sensors can also be used to monitor critical system and infrastructure, providing real-time data for secure, decentralized decision-making. Let's think again. Let's think again. For example, a nano-scale pressure sensor, in a pipeline, what can it do? A nanoscale pressure sensor in a pipeline could detect when a leak is occurring and automatically trigger a smart contract to initial repairs. This, of course, could help prevent environmental disasters, reduce costs associated with manual monitoring, and increase the efficiency of infrastructure management. What do you think, Jeff?
Yeah, again, another fascinating area, you know, this kind of automated economy that we're moving into. You know, processes are triggered and automated by blockchain. I think, you know, it's hard to grasp how ubiquitous and, you know, at the scale that blockchain is going to disrupt the global economy. I think it's so fascinating. And nanomaterials, of course. I mean, another fascinating industry. Have you heard of, can I ask a question? Have you heard of carbide?
Yes.
I'm sure you have. I came across it recently, again, just doing some reading, and it just seems, again, like this revolutionary, strong material. You could almost indestructible, you know, like a tube of carbon with graphene, you know, wrapped up by graphene. I mean, it's just insane to me that we're getting to this capability to build these kind of materials. And yeah, the implications are amazing. Yes. Well,
I will bring you some samples next time when we have a chance to meet up.
Oh, please, I would love it.
You can physically touch it, then you feel different.
I'll get an electric shock of it. Well, you're going to be in Las Vegas, is that correct?
Yes, I will.
Okay, excellent. Well, to the community and future listeners, you know, if you want to come and ask Professor Gur some questions about VeChain and nanomaterials, he will be in Las Vegas in March 4th. So be there, and I'll be there too. So that's fun. Okay, moving on. So how can nanomaterials be used in sustainable technologies specifically then?
Okay. Nanomaterials can play a very important role in sustainable technologies, as they have unique properties that can be leveraged to create more efficient and environmentally friendly solutions. Solar panels may be made with greater efficiency using nanomaterials. For instance, solar cells may produce more power from the same quantity of light by using nanoscale materials to enhance their ability to absorb light. Nanomaterials also have the potential to improve the efficiency of energy storage devices, such as batteries. Everybody use. Let's think about examples. Graphene may be utilized to make high-capacity batteries that store more energy in a smaller form factor, making them more suited for usage in renewable energy systems. Water filters made of nanoscale material may remove contaminants from water more efficiently and effectively, requiring less energy in the process. The usage of nanoscale materials may be employed to make filters that are more efficient in removing airborne contaminants, requiring less energy to do so. Nanomaterials can be used to create biodegradable plastics that break down more quickly, reducing the amount of waste that is generated and helping to protect the environment. This is what I think, Jeff.
Love it. And again, just from my own readings, another cool use case I saw with the solar panels was that graphene correct me if I'm wrong, you're the expert, but it can interact with the UV wavelengths. So you could potentially have, on a cloudy day, still able to get the UV photons, which are, of course, the more high-powered photons, and then get more energy from solar, more efficiently anyway.
Yep.
Yeah.
Thank you,
No,
Jack.
fascinating. Really, really fascinating. I'm going to ask you a lot of questions in Las Vegas. Okay, and then so we're almost through the session now. I see we've almost hit the hour, so I'll probably make this our final question. Yes. So one we're all interested in, carbon credits. We've heard a lot about it. How will nanomaterials play a role in gaining carbon credits? Generating carbon credits.
Carbon credits. Well, nanomaterials definitely play a very important role in gaining carbon credit. Carbon credit is a treatable certificate that represents the right to emit 1 metric of carbon dioxide or its equivalent in other greenhouse gases. Carbon credits are used as a tool for reducing greenhouse gas emissions and a part of a broad policy framework known as carbon pricing. Nanomaterials can significantly contribute to getting carbon credits by assisting the development of novel technologies that reduce greenhouse gas emissions. I'm going to use a lot of examples. For example, nanomaterials can also be used to create more efficient building materials, such as insulation and windows, that reduce the amount of energy required to heat and cool buildings. Nano coating can also be applied to windows to reduce the amount of heat that is transferred through the glass. The nano coating is made up of a layer of nanoscale materials that reflect heat, preventing it from entering the building. The reduces of amount of energy required to cool the building, saving energy and reducing greenhouse gas emissions. By reducing their greenhouse gas emissions, businesses and organizations can acquire carbon credits, which they can then sell to other organizations wanting to offset their own emissions. As a result, companies and other organizations will be able to treat carbon credits for the right to release greenhouse gases. Jack, I'm very interested in that. I'm very happy to hear that you like the researches that I have done. I'm not sure if you like to hear something more about graphene and carbon nanotubes.
Oh, please.
Or how can they help us revolutionize the next generation of electronics?
I would love to hear that.
I'm not too sure it's too much or if it's any interest.
Oh, yeah, I think so. I mean, your expertise is very relevant to the community. These things will be on VeChain potentially. So, yeah, by all means.
Yes. Okay, so if you don't mind, I go a little bit further on graphene and carbon nanotubes. It's probably a little bit more academic, but it is definitely helps for VeChain in the future, which I think it is helping us revolutionize the next generation of electronics. Well, two of the most promising nanomaterials being explored for application in the next generation of electronics. What are they? Jack, what are they? They are graphene and carbon nanotubes.
Nice.
Remember that it's graphene and carbon nanotubes. Graphene is a single layer of carbon atoms organized in a hexagonal lattice, making it an outstanding electrical and thermal conductor. As a result, it's a potential materials for making what? For making the high-speed low-power electronic devices including all these transistors, memory devices, and sensors. Graphene is also extremely strong and flexible. It is extremely strong, Jack, and flexible, making it a perfect material for wearable electronics and flexible displays. Carbon nanotubes are tiny tubes of carbon atoms that can be several micrometers long, but only a few nanometers in diameter. They have distinct electrical and mechanical features that make them suitable for use in a large variety of electronic devices, including all the transistors, memory devices, sensors. Carbon nanotubes are rigid, making them an excellent candidate for nanoscale devices and high-performance electronic components. All our researchers and engineers can produce quicker, more energy efficient, and next generation electronics by using the special properties of graphene and carbon nanotubes. The way people engage with technology might be completely altered as a result, opening the new opportunities for innovation in all different industries. Sorry, Jack, I hope it's helpful, or if it's too much, but I think I'm reaching to the time restrictions limit.
Yeah, no, it's fascinating to me. I love it personally. I'm very interested in this world. I had a really cool but hypothetical. Maybe you've heard of it, but do you know stannine? I don't think it's been created yet, but it's 2D tin, and it's like hypothesized to be superconductive as a material at kind of room temperature. You know, it's supposed to be like another really amazing conductor. I don't know if you ever come across that in your research.
Yes, I do. I probably give you a lecture while I'm in Las Vegas if you buy me a beer.
Oh man, so that'd be the best value for money I think I'll get this year. Thank you very much.
No, thank you.
Pleasure. It's been a pleasure. Well, I see we've basically hit the top of the hour now, so I know you're a very busy man. So maybe we'll leave the questions for Las Vegas if people want to come along and speak to you in person. But Professor Gur, it was fascinating to hear from you. Have you got any final words for the community and any future listeners?
I hope I can